The universe we live in today was molded by events that occurred during the first few seconds of the Big Bang. Marcelo Gleiser is Appleton Professor of Natural Philosophy and Professor of Physics and Astronomy at Dartmouth College. He investigates the origins of the forces of nature and other questions at the boundaries of theory and evidence.
People ask me why I am a scientist. Why is it about science? And it sounds so boring, to do all these calculations and give lectures and all this stuff. I mean, why aren't you a lawyer, a doctor, be a medical doctor? And my answer is that I just could not be anything else, because I find it a great privilege to spend every day of my life trying to unveil a little more about the mysteries of the universe, about the mysteries of nature. And even if our contribution is tiny, just to be part of this process of discovery, for me, is the most spectacular and stimulating thing I could dedicate my life to. I'm a cosmologist, and a cosmologist is a scientist, a physicist in general, that is interested in understanding the origin and evolution of the universe. So we ask very, very big questions, perhaps the biggest questions that could be asked, about how everything came to be and how from that beginning we got to where we are now. All cultures that we know of have somehow tried to give an answer to the question of the origin of the world. We know of them through religion, because before science dealt with these issues, these were issues that were dealt by religions all over the planet from different cultures. So science, in a sense, is trying to continue this line of inquiry by explaining in a quantitative way how everything came to be. We have problems because we have to deal with the most complicated of all issues in science, which is the question of time. We are very used to time, and time for us is a very simple thing, it just keeps flowing like a river all the time. But it's a little more complicated when you start to think at the beginning. So according to modern physics, we have a quantum era in which the concept of time and even the concept of space just doesn't make sense. You have a bubbling soup of little universes which can have all sorts of times, all sorts of spaces going on there. And ours happens to be one bubble that grew up and started to expand, as opposed to others that were just failed universes that just fell back into nothing. But the important lesson here is that in order to understand the physics of the very large, to reconstruct the history of the universe, you actually have to understand the physics of the very small, particle physics, the physics that describes the smallest constituents of matter. So there is this inner space, outer space connection, which is really very important in modern cosmology nowadays. So where do I expect things to move on, in the next few years? Where do I think the big discoveries are going to be, or what I would hope them to be anyways? Well, the most exciting discovery that we could have right now is life in other planets. I find that to be absolutely fascinating and something that will change our understanding of who we are and where science is going to go for a very long time to come.